morning, everyone, and welcome to the Blue Marble Desktop webinar for the month of July. This is Sam Knight. I'm the Director of Product Management here at Blue Marble Geographics. Today with me, I've also got Raina Winters, who's one of our application specialists, and we're going to be demonstrating some of the basic use of the point database conversions job. So before we get to that, we just want to make a couple of announcements. If you happen to be going to the Esri User Conference this week, please feel free to stop by our booth. You'll find us in the exhibit hall. We'll be demonstrating previews of the next release of the Blue Marble Desktop, which is going to be version 2.5. There you can see some of the new features we're going to be rolling out, such as creation of geospatial PDF, job pipelining that's going to allow folks to connect one job into another for some unified, longer, more involved workflows. Some new coordinate conversion features, such as direct coordinate conversions from one projected system to another projected system, time-based coordinate transformations using a 14-parameter method, various updates to our LiDAR handling, a new tool that is actually going to allow you to derive your own 3 and 7 parameter datum transformations, and a number of general enhancements to the application. So please feel free to join us at the Esri UC this week, where you can get a live in-person demo from some of our folks that are out there. As well, you'll be able to visit us if you happen to find yourself at the ISPRS meeting coming up at the end of August. We'll be exhibiting ISPRS, where we'll be demonstrating both the new version of Blue Marble Desktop as well as Global Mapper software. So that's our upcoming announcements here. If you've got some spare time and you're interested in checking out some of our previous webinars, please feel free to take a look at our webinars page. You can see the URL right at the top of your screen there. We have our main webinars page where we list off all of our upcoming webinars, such as today's you can see on screen. We will be posting next month's webinars fairly soon, getting those on the website for Blue Marble Desktop as well as Global Mapper. But as well, at the very top of that screen, you'll see a link there where you can access our previous webinars page. That's where we'll be posting the recording of today's session as well as all the sessions that we have recorded in the past. So that's where we keep our archives. You can always go back and take a look at some other particular topics there and get to know Blue Marble Desktop and Global Mapper software both a little bit better. So again, today's topic, we're going to be talking about point database conversions in the Blue Marble Desktop. Let's go ahead and get out of our intro slide here and go over into the Blue Marble Desktop itself. So Raina is actually going to take us through the basics of a conversion of an Excel sheet. So she's going to be covering some things for us, like simply loading in the data, setting up some of the column settings, dealing with the numeric coordinate format for an Excel sheet. Some of the other types of data that we can handle through here are things like DBF files, CSV, comma-separated values, that is, as well as many other ASCII types. Whether or not we have a predefined scheme for those, a little later on, we'll be taking a look at bringing in some ASCII data that are in unknown formats that are going to be new to the desktop, as well as ODBC database connections. We don't actually have any live ODBC databases here, but we'll point out where we can actually load those in. And we're going to get around to first a single table conversion that Raina's going to walk us through, and we'll get into some stuff like turning that single conversion into a batch, loading in some more complicated data formats such as ASCII types, Seismic data types, and we'll see where that gets us through the session. So today's session, again, is sort of billed as a beginner to intermediate level and as a general introduction. So at this time, I'd like to hand it over to Raina Winters, our application specialist, who's going to get us started. Good morning, Raina.
Good morning, Sam. Thank you very much. I'm just going to take us through a very basic conversion using the point database conversion tool, which you can see right here. In your default workspace, it's going to be loaded up automatically. But if you don't have it in your default workspace or you're working in a new workspace, it's also accessible by clicking on this button up here, or by right-clicking on the project manager, going to Create New Job, Calculator, and then the Point Database Conversion option. But since it's already loaded in, we're just going to work right here in the default version. The first thing you're going to need to do is obviously load in your data. You can do this by clicking right here on the ellipsis. It's going to prompt you to select your input data. Again, you'll click on this ellipsis to find your input data. We have some automatically loaded in here, or some saved on our desktop here. We have input coordinates, an Excel file. In the case that you are working with a table of data that has several points, you can use the only load the first X amount of records by clicking on this checkbox, and you can set the number of records that you'd like to use here. But for us, we're just going to use the full table of data. You can click OK just to load that in. For an Excel file, it's going to ask you if the file that you're loading has a header. In our case, we do, so we're going to click yes. And if we would like to skip blank rows, which we will also click yes to. So it has loaded the data in here in our grid viewer with our longitude and our latitude data in separate columns, as well as some identifying information about our data. This is in WGS84 by default, so we don't have to mess around with our input coordinate system. But we do want to set this out to a different output coordinate system. So what we're going to do is double-click over here. And this is going to open our coordinate system selection dialog. The different coordinate systems that you can choose from are folderized. Over here we have different sections including geodetic, projected, and you can use this to navigate to different systems, which will then be displayed over here on the right-hand side. So for now, we're going to go to UTM, WGS84, and we're going to find UTM Zone 19 North. And double-click on that open. And just to show that one more time, we're picking 19 North. We can double-click here, or we can also click OK to select it. Once we have that set, we're going to want to define our column settings for this job by clicking on this column settings button right here. This will open up our column settings for this particular conversion. First, we want to define our input settings. That's just our input columns that have already been loaded in. It'll display the header for that column right in these drop-down boxes. So first we'll want to select the latitude, and it's already got the longitude set by default. Then we can set where we want to save our output points to after the conversion is run. It'll save this in either columns that we have defined that are already existing in the table, or we can add new columns here. So we're going to add some new ones now. We'll just name those. I'm just going to name this output northern, and we'll save that after the last column. If we wanted to, we could also define a different placement, but for our purposes, after the last column will work fine. And I will also set output eastern. And those are set. And as you can see, that has automatically created new columns for our output information. If we wanted to, we could also define output columns which will save our scale factor and convergence, but in this case, it's not necessary. Once those are set, you can just click on this OK button, and it'll have those settings in there. And then it'll know exactly which columns to use for your input, where to save the output information. Since we are just simply going from WGS84 back out to another datum using WGS84, it is not necessary for us to set a datum transformation. But if you did need to, you could just double-click on this right here and set that transformation. So in order to make sure that we have this set correctly, we just want to do a quick calculate. This will basically give us a little preview of what we got out. And as you can see, it has populated these two columns with our output information. Once we have confirmed that that is the data that we want and that it's accurate, we can click the Save button right here to save out our data. And this will just open the Save Data dialog. We can select the ellipsis to define where we want to save it to. And I will just save that in our Output folder. We'll save that as Webinar Output 1. And then we can save it as a specific type if we desire. We have several different types that you can choose from, including vector data that you can save it out as. For our purposes, we can just save this out as a standard Excel spreadsheet. And once we click Save, we'll go back here. We can click on OK. It'll confirm that we want to save the header information, which will basically save the first row of data as this header information that we've defined here. We can select that, and it will tell us that it has been saved successfully. That is a basic conversion using the point database conversion job, and now I'm going to turn it back over to Sam for some more advanced features.
Thanks, Raina. So that was a basic conversion on something simple like an Excel sheet. A very similar process can be used for things like DBF files, other ASCII data formats, and the ODBC data connections as well. So now that we've taken a look at some of the basics of working this job, we're going to get a little bit more complicated. And we're going to do things like bash the conversion. We're going to use actually the same settings we just defined for this single conversion, and we're going to apply that to some other similar sheets. We're going to take a look at loading in some ASCII data formats and how those processes go. And it's mostly a difference on loading the inputs. And we're also going to take a look at some really complicated data formats in here that some of you that work in the seismic industry are going to bump into. Now, you may not have had too many questions going along through the basic introduction here, but if you do have any questions, we do also have some other folks on the line that will be able to answer your questions as we go. You can use the questions tool that is usually loaded up on the right side of your GoToWebinar screen. We can answer your questions as we go, and we're also going to save a little bit of time at the end to answer some more questions as they come in. So please do feel free to send those in. Now, we just looked at that one single conversion. So our input coordinates sheet, I also happen to have in this sample data collection, I have 4 other sheets that are basically exactly the same. They are different only in the data they actually contain. So the coordinates are different, but the coordinate systems are the same, and the columns are the same as this initial sheet that we loaded in here with our 4 columns, the longitude, latitude, the test ID, and the test results for the particular location. So that's just extra data. Now, in order to do this, we don't have to load those in one by one. We can actually convert them all en masse. And the process for that is simply starting with a single conversion. So we have all of our column settings in place that Raina took us through here with the latitude and longitude from input, writing those out to new columns for the output northing and easting. And all we need to do to work with those is simply right-click on the job itself over in the Project Manager. And in the menu that pops up, we've got a few different options for either copying the job, saving it out as a settings file that we can reload, cloning it into an exact copy of the same job that you might want to modify. And down at the very bottom, you'll see this option for batch add. If we click batch add, what that's going to do is load our batch generation window. And what this allows us to do is load in multiple data files, and the actual number of data files is totally up to you. There's not really a limitation in here. Then there are all the basic settings around a conversion, except they apply to multiple files. So the first thing we're going to do here is add some data. So I'm going to click the ellipses at the top right. I'm going to go back to my source data folder, and I'm going to grab onto those other 4 files that we have that are all similarly structured Excel sheets. As I open those up, because these are Excel sheets, it is going to ask me whether or not they have a header. And so that's that same first row where we got the labels from the initial sheet. And so all of these do have a header, so I'm going to say yes. And then again, because this is an Excel sheet, the prompt inquiring about skipping any blanks that it finds in the document. Blank rows will cause errors in conversion, and they can halt the process sometimes. So I'm going to say yes, let's skip any blanks in the incoming data. And there we've got our 4 sheets loaded in. If you're working with a very high volume count, the data count right below that box will tell you just how many files you did load, and we'll be running through the batch. And then below that, you'll notice all of the familiar coordinate system settings that we had out on the main job window. However, they are grayed out. You'll see there's some radio options in there to either use particular coordinate systems or to not set a coordinate system at the moment. And you can't actually make any changes to those settings. The reason for that is we're inheriting all of the preferences for this job from that base job that we're using as a template. You can actually start a batch from scratch. When Raina took us through creating that first new job, one of the options there was to right-click in the project manager and create a new job. In there, you'll also see that you can create a batch from scratch, and that would come up with a similar dialog, and you would have the option to separately control this. Because we are using a job as a template, we don't need to make any of these changes. We're inheriting all of those from that base job. We can skip right down to the bottom where we have the output naming. So we have output modifiers that we'll put on the name, and what these represent are prefixes and suffixes that will be added to the incoming file name. So if we take a look here, I'll just hide my file paths on the input, and we can see the specific file name. So I have sheets named input coordinate 2, 3, 4, and 5. If I add a output modifier prefix of, let's say, just simply output underscore, I might actually put something about the coordinate system that I'm going to put in there. I might, if we're doing a conversion to UTM-19, maybe I would put UTM-19 as a prefix or suffix in there. That prefix is going to be added onto the original file name on my outputs, and we'll actually see that take place in the output file name. So keep an eye out for those prefixes once we generate our batch list. As well, the output format, we can either say same as source, meaning same as the source data. So we've loaded in 4 Excel sheets. Those would go back out as Excel sheets, or we could actually convert that to something else. And then you'll notice all of those same basic types that we have in there, things like Excel sheets, T-based formats, all of the vector file types so that we can convert these to, things like AutoCAD, the various Esri formats, MapInfo formats. We can write these out as GPS Exchange if you're looking to convert tables of points out to something you can load on a GPS file. And as well at the bottom, there's some extra settings there that we didn't see on our initial file output. We've actually got some geodatabase options down there. Spatial databases in the Esri format, from ArcSTE to the file and personal geodatabases, as well as Oracle and PostGIS spatial databases as well. So there's a number of options there for the output. I'm going to keep this simple and write these back out as an Excel sheet, and because I am picking Excel, it is going to ask me about those headers, whether or not it wants to maintain them in the output one more time. So I'm just going to say yes, let's keep our headers for this output, and then I just need to simply define a folder where those multiple files are going to be written. And I've already got a folder saved right on my desktop called output that we're going to send these back to. Now this isn't actually the batch itself. What this is doing for us is simply generating a batch. As we generate at the bottom, you'll see a progress bar very quickly snaps by, and it returns us back to the main job screen. There's going to be this new batch point database conversion job added to our project manager, and we can actually go back and add more files to that. We can take some of the files out of it that have been added to it, or we can actually create other batches with completely different settings. The reason for all of this is that we're going to run it from the project manager. We can actually batch batches, if you will. So we could create multiple batches of unique settings and run them all as a group right here from the project manager. As we take a look at any of these individual jobs, you'll see each of these has their own blank settings that are applied to them. They each have their own data coming in from them, and they also have those unique output file names. So there's the prefix we added as the output modifier. So we're going to see our outputs coming out as output, and in this case it's a little bit of a silly name. It's going to be output input coordinates, and that's going to go back out as that Excel sheet. Once we can inspect all of these, we can see each of the distinct files that are going to be created from these, inspect all the settings that are going to take place. We can simply go back to our main batch, the parent node of all those entries in the list there. We simply right-click on that, and we're going to go down to Process. When we process that batch, you'll notice the Process Manager at the bottom of the screen. It's going to start putting up some progress bars. Because these are simple tables, they're very quick to convert, so we don't basically the progress bars fill up before we can really notice what's going on here in our demo. But all of these will slowly populate, and there will be a progress bar for the entire batch itself. So if you're doing a very high throughput batch, you'll be able to monitor the progress as that goes. If there are any problems, such as maybe a corrupt file or a file that isn't accessible in your batch, these will turn various shades, either yellow or red, indicating that there's a problem. And if there are problems, you'll be able to follow the messages report. That's the little tab at the bottom right there next to the Process Manager. And the messages will tell you what sort of problem has been encountered during the batch. We had no problems, so luckily our batch was nice and smooth. Then in our output directory, you'll notice we have all of those output sheets in addition to metadata files that have been automatically generated for each of those files. The metadata, again, is a part of every individual job here. You can actually access that metadata and apply any edits you want to before the way out. There is usually a base template included with some of these. If your incoming file has a metadata sheet associated with it, that can also be updated and automatically written out with the outputs of those data. So that's the sort of a quick and easy batch. Really the only differences on a very high throughput batch is the number of files. The basic assumption on the input is that all of your coordinate systems and all of the columns simply need to be consistent from file to file in your batch. But you can actually run, again, multiple batches. So you can have 2 batches, 3 batches, however many you need to encompass all of those different coordinate system settings. So next, we'll take a look at actually loading in some more complicated data formats. I have a couple of samples, and I'm just going to open one up here in our input. I have a made-up file format. So this is a file format that is not a real extension. You'll see it's got a .bmg extension there. I'm simply going to open this up in a text editor so we can take a look at what's in it. And you'll notice that it's exactly the same data that we got from the Excel sheet. So it's just simply stored in a different structure. For those of you familiar with ASCII data, this is going to look fairly simple. And it looks pretty much like a comma-separated values table. However, there's a couple of key differences. First, and the most obvious, is the file extension itself. It has a .bmg extension. So we could maybe rename that to a .csv and load it in using a CSV scheme, but it's actually got some other differences as well. Most notably, this first row of the file has column names rather than data, and CSV sheets very often do not have any sort of header name in the first row there. So there's a couple of differences here between this and your average CSV file, and because of that, it really is a distinct format. And with that distinct format, what we can do is give it its own scheme so that the desktop can actually permanently recognize the structure of data files with that extension and that layout. So to take a look at this, I'm going to go up under the Options menu. And you'll see there's a couple of options here. There's text file schemes and there's Seismic survey formats. We'll come back to the Seismic survey stuff in just a minute, because this is the Seismic survey is essentially a more extreme version of a regular ASCII file. So in the text file schemes, you'll see there's a drop-down in the top that has the normal out-of-the-box formats that we support. So you'll see there's CSV right there. We can select that, take a look at the file structure of it, delimited text, it uses commas, there's no header records in the default scheme there, and so on. But what we really need to do here is to create our own. So I'm going to simply punch in BMG for the unique file extension. That's how the desktop is going to recognize that format. And I'm going to add that to the list. And you'll notice when we do that, that gets added right into the bottom of our list there. And I can put in a file description. And the file description is going to be used in the menus when selecting some of our formats. So I'm just simply going to call this a Blue Marble file. There's an option here for a seg header type. This is only used with very particular types of data called seg data. Those are a number of different formats that are used in the seismic and hydrographic surveying realms. If you're not familiar with what that is, you probably just want to stay right away from that drop-down. Most data types are not actually seg data. If you do have seg and its variants, you can work with those header types. Other than that, you're going to just want to leave that set right in that. Then there are two main types of ASCII structure. The first is delimited text, and that's actually what we have here. Delimited text means you have some form of punctuation or some character that separates each column in the row. So if you remember our structure here, it actually has commas separating each column from the next. Fixed length fields we're going to come back to with the next data file we're going to take a look at, and we'll see how that's different. That relies on line spacing to actually break up the columns. So in a delimited text file, we have some sort of standard punctuations that are used to mark the columns. There is also a custom field. You can enter a custom character, whatever character you've got, if it is one of these non-standard punctuations. So ours is comma separated, and a text qualifier is sometimes used to have longer, very often natural language entry. So maybe if you have a comma separated file and one of those columns contains something like a last name, a comma, first name, it's really one column. It'll be surrounded by usually single quotes or double quotes to say that everything in between these quotes is actually one column. We don't have any of those, so I'm going to set that to none in this format for mine. And then the other way this diverged from that original CSV scheme was that it actually did have a header record. And there are various options in here. Either the total number of header records is very often going to equal 1, or there's going to be some options for more complicated schemes that will define recognition of multiple row headers in the top there. The field names below that, we can either use defaults, such as C1, C2, to indicate the various columns, or very often if you have one header record, you're going to use that option that the last header record contains the field names. So if you have one row, it's going to be the first and the last record, and in our data file, that is the case. We have nice column names in that particular first row. Below that, the data records can either start right after the header, or in some data formats, they'll actually be coded with a particular character, and we'll actually see that in seismic data we'll take a look at. I can say OK once my scheme is all set, and that's all it takes to define a new scheme. Then to actually see that in action, I'll create a new point database job. Oop, I just added that into my bash. Didn't mean to do that. I'm going to separate that out so it's its own outside of the bash job. And then I'm going to go to load a data file. So I'm going to go up to the ellipses in the upper right. We can then browse through that collection of data that we have. And we'll notice that now in the supported file formats, if we click that drop-down, you'll see there's a new entry here for Blue Marble File. So Blue Marble File as the description that I punched into that text scheme, and it's going to recognize the .bmg format. And as such, we'll see that as a supported format for loading data in. When we select the particular file and open that up, you'll see that comes right in. All the columns are laid out. And then from here, conversion is exactly the same as Raina demonstrated for us before. We can simply go into the column settings dialog, pick the appropriate columns for our input, add some to the output, and we're going to be off and running. So I'm not going to bother actually going through the whole conversion on that, since it really is identical to a conversion of any other file once we've got it in there. Now, back in the text file scheme, there are more complicated formats. And you'll see there are the options there for fixed length fields. And those have very different options for bringing these in. I do have another sample file that we're going to take a look at here. And this is a completely bogus file. It doesn't actually have coordinates in it. But I have this just because it's very simple to use to describe how a header works, how headers and how fixed width schemes work. So again, this is just a format we've made up. It's a ZZZ extension. And you'll see there are multiple rows of header at the top of the file. Each of these rows is started by an H character, and that helps us recognize multiple header records. That's very common, used in seismic data structures as well as other fixed width formats. Then the fixed length part of that gets down into the data file. So you'll see this is simply populated with 1s, 2s, 3s, 4s, and 5s. The first column is going to be represented by all of the ones that are in there. And then you'll see after that it switches over. And in every row here, the first column is the same width, and the second column is the same width, and the third column is the same width. They're not all equal to each other. They can all be different total widths, but they all stop at the same position on the row. That's what's called a fixed width file. And this is very common in some of the older data structures that are out there, such as seg files, UCOA data, SPS, for those of you working in the seismic world. And it can be a fairly complicated format to work with. So instead of dealing with this in our regular text fields dialog, you can do this if you simply have a file specification that tells you how many columns there are and how wide each one of those are as well. But we have a wizard mode that actually makes this a little bit easier if you don't have a full specification sitting right in front of you. So I'm going to click over to our wizard mode, and you'll see the same basic options, but we add a graphical interface on top of this. So I'm going to add in the unique file extension of ZZZ for my make-believe file here, and I'm just simply going to call this Sam's file, since this exists nowhere other than in my sample data set. I'm going to toggle it over to a fixed length field, because I know what the data structure is there, and then we're going to load in a sample. So we're just going to click that little load link, and it's going to grab for us all the files of that extension. And then it loads the preview at the bottom of the screen. From there, that just simply shows you the preview. We can go on to the next dialog and start getting some of the settings. So the first setting here, we're going to handle specifically the header records. Now, there's a couple ways you can handle some of these. If you've got just, say, a one-off file that is by itself, we can just quickly count the headers, and we can see that the header goes down to the 5th row. So I can just simply enter a 5 in there, and that's going to highlight those first 5 rows that represent the header. Or in this case, because we also have those H characters at the start, I can say all of the headers begin with this H character. I'll say OK. There's a setting right below that called block length, and that gets into another thing basically called a logical block. So you might only have your H's spaced out every few rows. For instance, the seg P1 format relies on an H being on every 20th row, some pretty complicated options in there. But you're simply going to set these up such that the appropriate chunk of data is highlighted for you. Then on to the next screen, and here's where we add in our field lengths. So you can, if you have a specification, you can simply punch in the number of fields if you know where they are, or you can simply point and click on the interface. So what I'm going to do here is find the spot in between those first 2 columns where my 1s turn into 2s, and I'm going to double click. When I double click, you'll see a red line appear on the preview, and you'll notice that the settings automatically change for us. So all we need to do there is double click on each of our column breaks. And as we do that, it's going to count up for us the total number of columns. It's automatically going to punch in their widths for us, and we can very quickly select out where those breaks are. Now again, this is mostly useful if you can very clearly see where your column breaks are. If you can't clearly define where those column breaks are, sometimes it really does help to find a specification if you're working with a new type of data. So on to the next setting here, how we're going to name those 5 fields that we've just defined. Because there are no field names anywhere in here, I'm simply going to leave this as using the defaults. Then recognition of the data records. They typically start right after the header. So the header are recognized as those rows with the H's on them. Everything after that is going to get picked up as data. Or if we had an alternate character, very commonly you'll see data records might begin with a D. And so we could add those characters in and they'd be picked up as such. Those are all those same settings we just looked at in what we call our classic interface, just done through step-by-step in the wizard mode. And the wizard mode, again, is mainly useful when defining these fixed width schemes for a format you're less familiar with. So I'll finish that off. And again, just like before, we can now go and load that data file in. It's recognized as a fixed length format here, recognized ASCII format. And we can open that up and see that all our columns are going to be broken out as we've indicated, and we have those default field names that are going to populate at the top. Again, from there, assuming we actually had real coordinates in this sample file, we would go right to the column settings and set the drop-down to match the various columns as they come in from our table. And just one very important thing to note, I don't think we've mentioned it yet, is that there is no required structure of data that is loaded in here. That first set of sample data we had the longitude before the latitude, but that's really just by chance. It can just as easily be latitude and then longitude. You could have latitudes and longitudes or northings and eastings in any column along the table, because you're going to use that column settings dialog to define exactly where your input comes from and where your output is going to go to. So the ASCII data formats are very commonly used for some more complicated operations involving seismic data. And because of that, in our most recent release here, version 2.4 of the desktop, we've added in a specialized variation of the point database conversion job. And this is really designed to specifically handle some of these specific data structures that we find in seismic data. You'll notice there's a key difference here between the seismic survey conversion job and the point database conversion job. And for those of you in the seismic world, you're probably well familiar with these, but for those of you who are not, these data structures very often have multiple columns of coordinates involved. So on the output side, you'll notice instead of having a single coordinate system, we actually have an output projected coordinate system and an output geodetic coordinate system. So we're going to be dealing with northings and eastings as well as latitudes and longitudes. And maybe just one or the other, but there is the possibility of both in there. As we load in various formats, you'll see we can bring in any of those seismic formats. The typical ones are going to be STAG, UCOA, SPS. As we bring those in there, these are very often recognized with variation. First, I'm just going to load this in here using the default scheme. And you'll notice the data structure that comes in is rather complicated. There's 15 columns in there. There are some strange-looking latitudes and longitudes that rely on particular data formats. And there's also, in this case, placeholders for eastings and northings. We can use the various options here to set what coordinate systems we're going to be reading in from and writing out to. But the reason for having both of those on the output is because we can simply read from one set of input columns and convert those both out to something else. Typically, maybe on a different datum would be a reason for going out to the latitudes and the longitudes. On this setting, rather on this job, you'll notice there are no column settings. That button is completely missing from this interface. And the reason for that is because these seismic formats are very rigidly defined. You can't just have your columns in any old place. They are always in the same position. So we actually know where those positions are as we load the data in. And because of that, on the seismic job, all you need to do are toggle on or off which systems you're going to be writing out to. If you select a latitude and longitude system for input on that seismic job, we know where the lat and long columns always live. And if you toggle to write those for output, we know where they're going to go for output for lats and longs, as well as the northings and eastings, since they are always in the same position. So that's just a very brief overview of the seismic survey job. It is a topic we have done webinars on in the past. So if you are interested in going a lot more in-depth on the seismic survey job in particular, I would encourage you again to check out our website where we post our previous webinars. You can find a link to the main webinars page here right off of our main site. And then from the webinars page, you can very quickly get to our archive page. You'll find all of the videos of our past recordings hosted via YouTube. So you are free to browse those at any time. And we do have another complete hour-long session devoted specifically to the seismic survey conversion. So what we've taken a look at today are the basics of the point database job. There are other places where this gets a little more complex, things like loading data in from ODBC database connections. The differences there are found right on that input menu. You'll see there's this type drop-down. You can click that over to an ODBC type, and then we can connect up to particular types of databases. These rely on pre-existing ODBC connections on your machine. So you need to first define your connection to, say, an Oracle database or a SQL server to get tables out of there. Obviously, you are also going to need appropriate username and password credentials to get into those if you have any sort of password locking on your ODBC databases that you have in-house. Conversion on those is just the same. So you're going to be dealing with all of the same column settings as you bring those in. And as well, Raina also pointed out for us the partial loading option that we're going to be dealing with when dealing with some of those more complicated types, such as ODBC, where you may be actually accessing a very high volume of data. That preview setting is very often used with the database connection just to keep from overwhelming your local system by fully loading an entire table into memory. That can sometimes bog down your system. And so if you're unsure of exactly how big a particular file is you're bringing in, you may just want to partially load it as a test. When you do partially load those data formats in, the interface does change to allow you to write out directly to file rather than processing on screen. And those do actually run the entire table that you've specified, whether it's an ODBC source or if it's a file-based table such as our Excel sheets here. Along with that, there is no upper limit to the size of data that can be handled within the interface here. That is one of our most common questions. And I see that question's actually come up today already in the session. So there is no upper limit. However, you do have practical limits on your own machine for how much you can load into view at one time. Using that partial loading technique, you can process millions upon millions of coordinates in here. The seismic data formats themselves very often go into the millions. The millions of rows of data in the sheet, that is. So that's pretty much going to wrap it up for the material we wanted to take a look at up front. So we can take a look at any questions that have come in over the hour now. I see one question has come in. How do you know what coordinate system to use? Looks like Carl's already answered that offline, but I just want to point that out for anybody else that happens to be watching. The coordinate system to use is one of the more complicated things, and unfortunately, that is one of those things that you simply have to know. So for the examples that we've been looking at here today, we own the data. We know that those input columns are latitude, longitude, based on WGS84. If you are using data that you sourced from somebody else, then it can get a little bit trickier. So the publisher of the data, or if somebody generated this for you from maybe a GIS system, or if they, maybe they just picked some points out of Google Earth, whoever handed you over these coordinates also needs to give you a definition of the coordinate system. And that can be as simple as saying these are lat long based on WGS84, or if you're here in the States, you might get some coordinates that are based on the older system, NAD27, if you've got lat long. But just as likely, you might be given northings and eastings in a projected system. And that is simply required data. So if you're dealing with northings and eastings, as we have here for our output, we knew that we wanted to convert these out to UTM Zone 19. For our purposes, that's simply because we're located here in Maine, in the United States, and a lot of our local mapping in the region is done in the UTM coordinate system. All our state data is published on the state data library in that coordinate system. It's something we very commonly work with here. Other places around the world might have different standards. Let's say, for example, you're a user in the United Kingdom. You might be working with British National Grid as sort of the common survey standard for that part of the world. If you're down in Australia, you might be working with the Australian map grid on various alternate datums. But the coordinate systems for input are simply, you need to know what they are, and if you have data, the person that gave you that data should know what it is. If they don't, that gets into a much, much trickier conversation. But really, it is just simply one of those pieces that that does need to come along. Let's see, another question is coming in here. Can you make the output file only contain some of the total data sets? The easiest way to do that would be to take advantage of the partial loading setting, such as we did when we brought in. Actually, I don't think we actually loaded any data partially, but the setting takes place as you load in the input. So when we toggle on to only load the first so many records, in this case, say 50 records from our data file, that is going to load 50 records into our data grid on screen. So in this case, the first 50 records. If you've got data that goes beyond that, it's simply going to be deferred until you run the entire process. And when you run the entire process, that will typically do the entire data set for output. If you do simply only an on-screen amount, you run a preview and save that out, that will essentially stop the output at those first 50 rows. That's as simple as it gets for just loading in mass quantities of data from something like an Excel sheet. There is not yet any decimation capability. So if you have a common question folks will be looking to do is, do you want to load in a very heavy piece of data like a seismic file, and you want to grab every 10th point? That's not something we yet have the capabilities to do. We are exploring that for the future, but it's not one of our current function sets. There are other methods to load in partial data if you're specifically talking about some of the ASCII format, and that comes from our text file schemes. Some folks use this to pull out specific records that are identified within a file, such as GPS data, raw GPS data, for example, in the NMEA structure, has coordinates only on about I think it's every 20th row there's a coordinate. And every row that has that particular piece of data begins with a certain set of characters. So if you're coming in from an ASCII format like that, you can isolate data records that all start. Every row would begin with a particular set of characters. For that NMEA example, it would be something like $GPGLL. That's just the code that says this row contains coordinate data in that particular structure. There could be any number of different ways to specify that, but in the context of ASCII data, you'd use those data records settings to recognize those out of there. I'm not entirely sure if I've answered the question as you intend, so please do feel free to follow up with us after the fact. That will we can get a lot more specific and hopefully answer your real question there. Another question on the cost of the software. The cost of the software depends very heavily on the licensing options. We do have bulk discounts. There are subscription options ranging from single user licenses to network licenses. And essentially the breakdown there is the more seats you purchase, the better economy you're going to get for the cost per seat. For specifics on that, I'd encourage you to get in contact with our sales team here. That's simply sales@bluemarblegeo.com. They can get with you on the specifics of a single-user node lock versus dongle versus network licensing options, and they can get you a quotation on that very quickly on the specifics of just how much license you're looking for, basically. That's pretty much going to wrap it up. I think we've taken care of the questions that have come in. If you do have any further questions, please feel free to send those into our support line at geohelp@bluemarblegeo.com. That is geohelp@bluemarblegeo.com. Our tech support team is always there answering questions, and we can get back with you for any remaining issues you might have questions on. That said, that's going to wrap it up for us today. Thank you, everyone, for attending. Thanks, Raina, for helping me out today. And we will hopefully see you all next month at the webinar. So keep an eye out on our upcoming webinars page. We'll be announcing next month's topic very soon. So thanks again, and have a great day.